Hello YouTube viewers, welcome to my show Science Thursday. Today is episode number 3. So today we're going to take a look into the LED. So the question comes to the mind, what is an LED? In simplest term, LED stands for light emitting diode. Now how does it work? Very simply, it's an electroluminescent device. All that simply means is it takes electricity and directly turns into light. There is no conversion. So let's dive into it. Now, so LEDs are becoming popular. The question becomes why? Now you have to understand there are only two main competition to LEDs. One is CFL, another is this filament that you see in incandescent bulbs. Now suffice to say, this works on thermoluminescence. Basically it heats up, then it starts to glow, and that's why they are so hot. And it requires a glass casing, and suffice to say that is fragile. So is CFL. And CFL works by evaporating fluid, sometimes directly emitting UV lights, and the phosphorus coating in the tubes that you see starts to convert that UV light into broad spectrum white light. So they are both fragile. Like, that's their biggest danger. They are both fragile. LED can be used everywhere, but these puppies are very fragile. So let's dive into it more. Now you want to understand, let's in deep what happens. So all you have to understand, it's a PNN junction. What does that mean? Simply positive and negative junction. All it is, it's a one-way diode. Electricity can go only one way, other way it will not go. So how does it create light? Directly. So all you have to understand is, electron comes from the negative side, then it's having current going through it, has voltage, so it's getting excited, and there are holes in the positive side. Yes, they are actually called holes, and electron tries to go into the lower state of the holes, and while doing so it has to dump the energy that you put into it, the electrical energy, so it releases a photon. So that's how it can directly convert electrical energy into photons. It simply jumps to a lower energy state. You increase this energy state by electricity, it jumps to a lower state, and we design the semiconductor such a way that it forces electron to dump photons. So you get directly light. You do get some heat here, but most production are in photons. So that's how it works, and it's quite old technology. We've been developing this puppies from 1962. So if you guys must have seen your remotes, they use infrared LEDs, which are ancient. Like we've been building that shit for quite some time. They were the first use of LEDs. So then we have to look into what are their benefits. So first benefit is size. So as you can look into this, like this, LEDs are one small things. Now this panel is roughly 24 watts. So you're like, okay, this is quite big. Now you can take this. This is also 24 watts, but the LED chip itself is quite small. So if the reason why you see high power LEDs like this puppy require cooling is simply because all the dyes that are inside this chip is put so close to each other that even the minute amount of heat they generate starts to pile up. And because it's in such a concentrated area, it already increases the resistance of the circuit and thus forcing more current to it, which causes a runaway reaction. That's why they need cooling. And if you had normal LEDs like this, where even a simple aluminum sheet is more than enough as a heat sink. So if you want to have a LED light without heat sink, you can easily do it. It just will be big. So size, as you already saw, it's very small. Then cycling. Now this is a very important part for us. All the incandescent bulb, if you turn them on and off quite often, they're not gonna live long. CFL does bit better, but not that much. However, LED simply does not care. Like, it simply does not care. You can flicker it on off so quickly that there is a technology built on it called Li-Fi. Basically, it's an upgraded version of Wi-Fi which works on light, and the light is normal visual spectrum light, so you can see light. Here's the deal, but you can't see the flickering, and it's flickering 50-60,000 times a second. So suffice to say, it really does not care about cycling. Like, it's like, I don't care whether you turn me on or off. Then we have to come to life cycle, how long the system will work. Now incandescent bulb, good case scenario, 6 to 8,000 hours. CFL 10 to 20,000. This sucker starts at 30,000 hours and can go up to 1 million hours. So suffice to say, they live very long life. Now, efficiency, this is where people get a bit confused. I have seen way too many people saying that they are multiple times more efficient than CFL. No, LED that are single color, yes, they are very efficient, but white LEDs that you most likely gonna use are not that efficient. They still have 10-20% more efficiency on CFL, but not by a lot. So jump from incandescent light bulb to CFL is like multiple times, 8 times, 9 times, but at best case scenario, you will get twice the efficiency. Don't expect like, another 10x benefit. So be mindful, it's the most efficient way of lighting it, but it's not like, day and night difference between CFL and LEDs. However, the LED's lifetime makes it worthwhile investment. Now they are shock resistant, as I said, like I don't have to worry about them breaking their, I don't have to worry about it. It's going to be working fine. So they are quite shock resistant, and as already I mentioned, they all the counterparts are quite fragile. Now there are certain disadvantages. It's not all magic and all that. First disadvantage is they require complex drivers. Basically, they does not work on directly AC current. They require you to build constant voltage, constant current circuit, and suffice to say, electrical circuit that can drive LED properly are expensive. You can drive them inefficiently, but they're not going to live their 30,000 hour life cycle. So they have complex driver. Now this can be solved if you have money. However, one thing that still can't be solved very well, they have very bad color reproduction. Now this is the reason why LEDs weren't so popular. So we've been building them from 1960s. That's why they are not so popular. Generally, the LED lights are idiotically bad. Like in video production, people simply didn't want to use them because they give a skin a very sick sort of feeling, because or older LEDs, the white LEDs, they were actually blue ultraviolet LEDs using phosphorus to glow. Basically, they were behaving exactly like CFLs. The modern LEDs have RGB elements into it, sometimes chemically, which are much more efficient. And so the way you can judge whether your LED is good or not, especially if you buy chips of this size, they will come with a rating of CRI, Color Reproduction Index. Basically, higher the better. And 100% is like 100% sunlight. So you can easily get 80, 90, and they will be very cheap. However, 90 plus will start costing a lot. So be mindful. These are the two disadvantages. Now, I do not consider complex driver to be an issue. You can buy good ones. However, bad color reproduction really is an hindrance. That's why you need to buy really high quality LEDs if you want to do video works or plantation, or using greenhouse. So then the question becomes, okay, we learned about LEDs. Where are they? Short answer, everywhere. From street lamps to street signs, from TV to your mobile phone, they are everywhere. They are the literally founding blocks of our society's lighting needs nowadays. They are ever present, and suffice to say, you guys must have heard of our Samsung AMOLED. Samsung AMOLED is a quite unique thing because AMOLED screens don't last very long. However, Samsung knew that nobody was buying their phone for like 2-3 years, so they experimented on their customer. Customer was happy, badass display, but it had screen burning issues and all that, which nobody cared because they're gonna throw it away in next year. So that's how Samsung slowly, after lots of experiment, they became the king of AMOLED display. So as we seen, LEDs are simple simple semiconductor diodes. It emits light directly. That's why they are so efficient. There is no heating to glow. There is no converting UV lights to normal spectrum light. So they are very efficient, and we already looked at their advantage and disadvantage. Suffice to say, I do not under stresses. They are everywhere, even in your modem, and your optical fiber also runs on it. So thanks for watching. I hope you liked it. If you liked it, please like. If you dislike it, dislike, leave a comment, and please subscribe. And if you are free, press the bell icon. Thanks for watching.